How do you analyze a Wheatstone bridge using only KVL, KCL, and Ohm's law? Find out right now. Hi, I'm Dr. Bob. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering at your service. In this problem, we have something that is traditionally called a Wheatstone circuit. So we're going to have a power supply here, which is 120 volts, and then we'll have over here a Wheatstone bridge, and I'm going to draw this a little bit bigger than it needs to be so that we can fit everything in here. So Wheatstone bridge is traditionally made up of 5 resistors formed in a square. Let's put this, connect this up, and then we've got 4 resistors formed in a square, and then 1 resistor that goes across the middle. This is a common device that's used in measuring equipment. Alright, so this would normally be a pretty difficult circuit. We're going to call this is a 45 ohm resistor here. And we have a 10 ohm resistor right here, 8 ohm here, 30 ohms here, and then we have 40 ohms over here. And I think that's everything. So now this would ordinarily be, we'd have to work out what's called a delta Y transformation or a Y delta. But in this case we don't need to, because we've been given some information to begin with, and that is the voltage drop across this resistor, which is going to be 45 volts. Okay, so from here to here we measure 45 volts, and that gives us a hint about the rest of the circuit. We don't really need to do much. I mean, we can sort of just work right on through this. Now the question is, find the value of all the currents going through all the resistors, and I'm going to label these as I1, I2, I3, I4, and I5. Okay, so I've labeled and then of course the total current is going to be IT. So, and we're going to also get these currents going some direction. I'm going to assume that the current here is going that one. This current is going this way. This current is going that way. I5 is going that way, and of course this is going this way. So it's always going from a positive to a negative. We don't know which way this is going just yet, but we're going to try and see what happens here. Now, if I have a voltage drop, here's 120 volts, so everywhere across here, and I'm going to pretend that this is 0 volts, right? So relative to the 0 volts, I've got a 120 volt power supply right here. So this is 120 volts up here. So everywhere along this branch is 120 volts appears right there. And everywhere along this branch appears 0 volts. Okay, the question is, what's going on in between here? So ordinarily in this sort of circuit we have to do a lot of calculations, except that we've been given this value right here. So the first thing we can figure out, the question is, what is I1, I2, I3, I4, and I5? And then from these we should be able to figure out IT, which is the total current. So I1 is pretty easy. That's just 45 volts divided by 45 ohms. That's going to be 1 amp. Right? So if we have a 45 volt drop from here to here, that means this point relative to this 120 is going to be 75 volts. Well, now we've got I2 comes out right away. That's 75 divided by 30, which is going to be 2.5 amps. So that's pretty simple. We got 1 amp over here, I1 equals 1 amp. I2 equals 2.5 amp. I'm going to write this down over here. 2.5 amps. So I've got 2.5 amps coming through this leg right away. The next thing is, what can we figure out from here? We have 1 amp going this direction into this node. We have 2.5 amps coming out of it. We're going to assume that's the case. So in order for this node to be correct, we have another current that has to go into this, and that's going to be what? It's going to be 1 plus something is equal to 2.5. Well, that's of course 1.5 amps. So now we've got 1.5 amp going in, 1 amp going in. That totals 2.5 coming out. That gives us I3, which is 1.5 amps. Now, we have a 10 ohm resistor. We have current going this direction, which means this is positive with respect to this node over here, which is going to be negative with respect to that. But this is 10 ohm resistor times 1.5 amps. That gives us a 15 volt. That's a 15 volt drop across this resistor, but it's going up in value. So it's going to be 75 plus the 15, which is going to say this is going to be 90 volts at this node right here. Alright, 75 plus the 15 is coming to 90. Now that gives us the next little trick over here. Now we've got 120 volts over here. We got 90 volts over here. So that means we have a 30 volt drop across this 8 ohm resistor. Well, 30 divided by 8. And I'm just going to do this on the calculator. It's 3 points. So this is I4. This is 3.75 amps. So that gives us I4, 3.75 amperes. Alright, and now we have 90 here with respect to the 0 volts right there. 90 over 40, or 9 over 4. So 9 divided by 4 is I5, which is 2.25 amperes. Oh, that pretty much settles everything. 2.25 amperes. Let's see if all this adds up here. I've got 2.5 coming into this node from over here, this node right here. 2.5 coming this way, 2.25 coming up this way. That gives me this current right here, which is going to be 4.75 amps. That's going to be the total current, 4.75 amps. Now let's make sure that's correct. We got 3.75 amps over here, 1 amp over here. 3.75 plus 1 says this is also 4.75 amps. So this matches that, and that's correct. So our total current, IT, is 4.75 amps. That's all taken care of. Good. The next question is, what's the power through each one of these resistors? And then what's the total power? Alright, so P equals IV. I'm going to set total power, I total, V total. Now there are two ways to work this out. Total power, we want P1 through P5 also. But the basic way is the total current is 4.75 amps times the total voltage, which is 120 volts. And that comes out to 4.75 times 120, which is 500 PT equals to 570 watts. Okay, how do we verify this? We can go through each one of these and make sure they all add up. So let's work out. P1 is 1 amp times 45 volts, which is I times V, and that's going to be 45 watts. That's going to be our easiest calculation. P2 is 2.5 amps times, well, here's P2, I2 is going to be I2, which is 2.5 times 75, so 2.5 by 75 which is 187.5 watts. P3 is 1.5, of course P3 is I3 over here, which is 1.5 amps times the voltage times 15 volts, so we've got 1.5 times 15, which is going to be 22.5 volts per watt. P4, which is going to be 3.75 times, where's P4, which is going to be times 30 volts, which is 112.5 watts. And then of course the last one is P5, which is this one over here, which is going to be 2.25 amps times the voltage drop, which is 90 times 90, which is 202.5 watts. So PT is just add all these guys up, right? Just add them up, that should be the total. So let's say 45 plus 187.5 plus 22.5 plus 112.5 plus 202.5, which is equal to 570 watts. If you add all these up, you'll see that's my number on the calculator. It's my number on the calculator. Okay, get that upside down. So that matches this right here. And that is correct because these two guys are equal. Alright, so that's this interesting problem. We'll see you next time. Dr. Butt. Thanks for watching my program. If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.